back, geometry scholars. Today's lesson is a continuation of triangle congruence. We're going to be talking specifically today about angle, side angle, side, and side triangle congruence. Again, these are terms that you are already familiar with because we have been talking about them in bell work, and they were introduced in the last class's homework. Our essential question is still, how does algebraic knowledge of lines help to solve problems about geometric concepts? And the lesson objective for today is that you will be able to determine if two triangles are congruent, and if so, be able to explain why. On the left side, you have the questions margin. If you have any questions, write them there. Or if any of these terms maybe possibly explain any questions you have, write them there as well. So far about triangle congruence, we know that ASA means angle, side angle. I'm going to try to highlight, and Smartboard's been giving me a hard time lately. Hopefully it'll work for us today. There we go. We'll do green. So angle, side angle, and it needs to be two angles and the included side. Okay, so two angles and the included side. Side angle side, SAS, stands for side angle side. That would be two sides and one included angle. And then SSS, side, three sides. And when I checked today during class, you guys seem to have an idea of what these definitions meant and what these terms meant and their definitions. Remember, it must be the included side or the included angle. So let's go ahead and practice this. And this is just basically a practice lesson of what we've been learning. We're going to state the additional information that's required in order to prove that the triangles are congruent for each theorem given. So, example A, we have triangle RST and triangle XYZ. And we're trying to prove that the two triangles are congruent using the side theorem. So, in order to prove this, let's look at what we already have. Well, we already have a side. Okay, RS is congruent to XY. And we already have another side. We have that ST is congruent to YZ. So we need a third side. We have a missing side. And obviously, we can see which side we're missing. So I'm going to name it RT. You could also call it TR. And that doesn't matter which one you call it, RT or TR. What does matter is what you call the second one. So if you have called this one RT, look where R is. R is the point that's on the side with two congruence marks. So you have to start with the point that's on the side with two congruence marks again. So I started with R. So I have to start with X and go to Z. So RT is congruent to XZ, or if you would have started with TR, you could say TR, but then you would have had to switch it around. And since you started with T this time, the one with the 3 marks, you would have had to start with Z because that's the one with the 3 marks as well. So it would have been ZX. So you can name it either way. It doesn't matter as long as you're consistent. Okay, as long as you're consistent. Let's try this next one. SAS. We need to prove these two triangles congruent using the SAS theorem. Well, let's look and see what we already have. We already have a side, EF and QF. So we have the side. Do we have anything else? Well, using our reflexive property, we know that GF is congruent to GF. So we have another side. So what's missing is the angle. Okay, we're missing the included angle. So it can't be this angle, it can't be that angle because they're not included. It's not between the two sides we already have. We need the angle that's between the two sides we already have. So we need this angle and that angle. Okay, and I drew the congruence marks slightly apart so you can see it's two different angles. Okay, so I'm going to name this angle. I'm going to start with E, F, down to G. So E, F, G. Notice G is the vertex, and it's the middle letter. And in order to prove these triangles congruent using SAS, it has to be congruent to another angle. And since I started at E for the first one, I have to start at Q for the second one. It's congruent to angle Q. F is still the middle. Q, F, G. Okay? And if I had that angle, I could then prove these two triangles congruent using SAS. So although it only started off by giving us EF is congruent to QF, using prior knowledge, we also know that GF is congruent to GF. So there's our two sides. So all we would have actually needed is that missing angle. And by having the missing angle, we can now prove them congruent. If you would have rathered, you also could have called this angle GFE. Okay, notice I switched the order of E and G. But if you do that, you have to call this angle then GFQ. Okay? That would be fine. Let's go down to example C. Example C, if I wanted to prove these two triangles congruent using the SAS theorem, what do I still need? Well, let's look first at what we have. We already know that LV is congruent to DV. And notice that I said LV and DV. Okay, I went in the same order. I went from L to V. So here I have to go from D to V. Okay, I can't say LV to and VD. Okay, so I already have a side. Got that taken care of. What else do I know? Well, I know that LVO is congruent to DVE. And how do we know that? What kind of angles are those? Those are vertical angles, and vertical angles are always congruent. So you already know that we have a side and an angle that are congruent to each other. So what else do we need in order to prove this using side, angle, side? Well, we are missing another side, and it has to be the side that's attached to the angle. So it has to be this side right here. Okay? So in order to prove these triangles congruent using SAS, we need, sorry, I should only mark that with one tick mark. We need this side. So it would be OV is congruent to EV. Or you could call it VO, go from the middle out. But if you go from the middle out to O, you have to go from the middle out to E as well. That's the side we need. So by having that side, we have now proved those triangles congruent using side, angle, side. That's what this lesson is. It's all practice of proving them congruent. Look at example 2. State the additional information that is required in order to prove the triangles that are congruent for each theorem given. Looking again, we have triangle KLM and triangle UTS. They want us to prove them congruent using the angle side angle theorem. What do they already give us? They give us K is congruent to U, and we know that because it has the one congruence mark, and we know that angle L is congruent to angle T, again, because it gave us the two congruence marks. So we have two angles. So now we need the included side. We need the included side. So what is the included side of this first triangle? KL, or you might have called it LK. Either one is fine. So KL is congruent to what side of the second triangle? Well, notice since I started at K, which has the one angle mark, I would start at its congruent point, which is U, because again, the one congruence mark. So U, T. Or if you did LK from the 2 to the 1 instead, you would go TU. Okay? What you cannot say is LK, sorry about that, LK is congruent to UT. That is wrong. Okay? You can't say LK this direction from the 2 to the 1 is congruent to UT, which is the 1 to the 2. That is the improper way of naming them. You have to make sure that you are consistent with the naming. Okay, so if we had that side, we could prove those triangles congruent. Let's move down to example B. Proving these using ASA, which is the angle side angle theorem. What do they already give us? They gave us that angle G is congruent to angle H, so we have that. Or I should say angle VGH is congruent to angle IHG. Okay. We also know that GH is congruent to GH because of the reflexive property, so we have the side. So now we need the angle on the other side of the side. I know that sounds confusing, but we have an angle, we have a side, so now I need this angle. We have an angle, we have a side, so now I need that angle. Okay? I'm going to name this angle VHG. And notice where I started. I started at this point. So I'm going to start at this point. Angle IGH. Okay. Angle VHG, okay, is congruent to angle IHG. I'm sorry, I wrote that wrong. My bad. IGH. Right now, you guys would all be yelling at me, Mrs. Locke, you wrote it the wrong way. IGH. Okay? Because G needed to be in the vertex. G is the vertex, so it's in the middle. And then H is the vertex point, so it's in the middle as well. So with that angle, I now have, I'm going to use red, I now have my angle, side, angle, and my angle, side, angle. There is my third piece. What's the other way you could have written these same angles? Okay, sorry about that. My screen switched on me. You could have written it backwards. Instead of VHG, you could have said GHV. Instead of IGH, HGI. They just have to be corresponding to each other. Okay, corresponding to each other. You are now on the back of your notes. 2 more examples. Let's try it. I want you to pause the video and try these problems. Okay, think about what it gives you. Think about then what you already know, and then think about what you need to know in order to solve these, prove these triangles congruent. I'm going to go ahead and stop this. I want you to pause the video, and I want you to try these next 2 on your own. Okay, on this one, they gave us a side. We also knew that these 2 angles were congruent because they are vertical angles, so we needed a our second side, our third piece of information, which would have been this side right here. It has to be on the other side of the angle. So EI is congruent to JI, or you could have called it IE, which just switches the letters around, is congruent to IJ. The other letters have to switch around as well. Either way of naming them is fine, as long as they're both named the same way. Example B, they gave us an angle. We knew that AM was congruent to itself, so we needed another angle in order to prove it congruent using ASA. So angle EAM is congruent to angle NAM. Notice they both have A, middle letter to the vertex point. Or again, you could have switched them around. MAE is congruent to MAN. Either way is fine as long as you're consistent in the naming. And if you have any questions about that, please ask me in class. I'm more than willing to give additional examples for that. Last thing before the summary. You need to determine whether the given information is sufficient to guarantee that the 2 triangles are congruent. So I either want you to bubble in or circle sufficient or not sufficient. Okay? Again, not that it could possibly be correct, but rather to guarantee that it's correct. Okay? And I'm going to walk through this with you. The triangles have 3 pairs of congruent corresponding angles. So angles, 3 of them. So A. Can we prove triangles congruent using the AAA theorem? No, we cannot. So that's not sufficient. We haven't even learned the AAA theorem, if there even is one. But We did talk about last bell work, actually, last class notes in Module 5, that 3 pairs of corresponding angles, congruent corresponding angles, is not enough, okay? So AAA is not enough. Letter B, the triangles have 3 pairs of congruent corresponding sides. So 3 pairs of sides, SSS. Is that enough information? Yes, it is. We can prove it congruent using the side-side-sine theorem. Letter C, the triangles have 2 pairs of congruent corresponding sides and 1 pair of congruent corresponding angles. So 2 pairs of sides, 1 pair of angles. So I'm going to write out all of the ways that this could be shown. Okay? So 2 pairs of congruent sides, side, side, and then angles, or put the angle first and side, side. Obviously, that's a bad word, and we'll never use a bad word to describe something in geometry, so that should tell you right away that's not an appropriate way or an appropriate theorem. Or we could take the 2 sides and split it up, put the angle in the middle. Now, we do know that side angle side, we can prove something congruent using the side angle side theorem. However, in order for that to be true, it would have to say the included angle. Does this say included angle? It doesn't. It just says 2 pairs of sides and 1 angle. And so since it could be written as SSA or ASS, which is SSA backwards, which is also incorrect, we cannot guarantee just by this information that they are congruent. So that is not enough information. Not enough information. Letter D, the triangles have 2 pairs of corresponding angles, so 2 angles, and 1 pair of congruent corresponding sides. So we could write this as AAS or SAA, which is simply that backwards. Okay? Or we could write it as ASA. Okay? So basically these two are the same thing, but it's called the AAS theorem. And we actually have not talked about this one yet. It's coming up in a few more lessons, but I wanted to throw that in there anyway, kind of give you some pre-knowledge. We actually can prove this one congruent. This is enough information because this is an accurate theorem, AAS, angle, angle, side. Sorry about that. This is an accurate theorem, and we also know that ASA is an accurate theorem as well. So this one is sufficient information. We have 2 more. Letter E says 2 angles in the included side of one triangle are congruent to 2 angles in the included side of another. So the important word here is included. So 2 angles in the included side, 2 angles in the included side as well. So that would be A, S, A, because that included side means S is in the middle. Is that enough information? Yes, it is. Last one, 2 sides and the included angle congruent to 2 sides and the included angle. So side, side, the included angle. Is that enough information? Yes, it is. So all of these should have been review and pretty easy except for letter D. I know that's a new term that got thrown in there. Remember, AAS is the proper way to call that one. SAA is the same thing, just backwards, but we don't call it side angle angle. We call it angle angle side. Or that information could have been angle side angle. We don't know which way they meant it, but either way they meant it, it's enough. Because if we have either piece, that's sufficient information to prove those 2 congruent. Okay, and we will talk more about that next lesson. Go ahead and please write a summary of what you've learned or any additional questions you have, and I'll see you next class.